This is a distance problem from early in the semester, and sometimes we kind of forget about these types of problems. So I definitely want to go over this one to make sure we've got it. Now remember, the ones that I'm doing today and here are different than what's on your practice test. So you're going to get another dose of whatever you need on the practice test. So I'm just picking out some like the practice test that students typically miss or whatever. So what we've got here is we've got two airplanes leave Nashville at 10 a.m. and they travel in opposite directions. See if you can open that. It may not. It may not work. If one travels 350 miles per hour and the other travels 400 miles per hour, at what time will they be 1,125 miles apart? Okay? So this is what's happening in this particular scenario. Here is Nashville, Tennessee, right here. So here's Nashville. And we have an airplane that's going this way, and then we have an airplane that's going this way. That's what's happening. One of the airplanes is going 350 miles per hour, and one of the airplanes is going 400 miles per hour. And they're going in opposite directions. So, in 1 hour, this plane travels 350 miles because it's traveling 350 miles per hour. And this plane in 1 hour, my children are texting me right now about their tests. Both of them. Bradley's not failing English. He's very proud of his 64. I am not very happy about his 64. And Madison texts, I mean, like, they can't even be together. I'm like, seriously, stop, not right now. So, motherhood. And the second plane, after 1 hour, has traveled 400 miles. So the total distance after 1 hour that they are apart from each other is how much? After 1 hour, how far apart are they? 750 miles. Okay, so we're adding those two distances together. And so that's the concept that we're going to use on this particular part. That's the concept that we're going to use. Okay? So you will be given this, or I will give you a formula sheet. And the formula that you are going to use for this is rate equals distance divided by time. Okay? That is the formula that you're going to use for this. Now, a very close cousin of rate equals distance divided by time is rate times time equals distance. Okay? So to get this, what I did was I multiplied this by t. So I ended up just solving for d. And when I did that, rate times time gives me my distance. Rate times time gives me my distance. So it's actually this formula that I am going to use to solve this problem. Okay? So, if I have, so we're going to label this plane right here that travels 350 miles per hour, we're going to label that one plane A. This plane that travels 400 miles per hour, we're going to label it plane B. This is plane B, and it travels 400 miles per hour. Okay? So, if I have the distance of plane A plus the distance of plane B, what is that going to equal? On this particular problem, this problem says, at what time will they be 1,125 miles apart? So what is the distance for this specific problem that I'm looking for? 1125. Okay, so that's what I want to know. When plane A travels one direction and plane B travels the other direction, I want to know how much time has passed when they are 1,125 miles apart. That's what I want to know. Okay? So, what I'm going to do for plane A, my rate for plane A is 350 miles per hour. So, I'm going to have 350 miles per hour times time. So, I'm given my rate. That's my R. I don't know my time, but I can keep it as T. What happens there is that right there, the 350 times T, is giving me the distance that plane A travels. That's what's happening right there. 350 is my rate for plane A. I don't know what my time is, so I'm just going to put time right there. But 350 times whatever my time is going to give me the distance that plane A travels in that amount of time. For plane B, how fast is plane B moving? $400, yes. So 400, okay, times T, that is going to give me the distance that plane B moves. So 350 times T is a distance, 400 times T is a distance. And when I add those two distances together, I'm going to have 1125. Okay? So now I have 350 times T plus 400 times T equals 1125. Okay? This right here is a problem that then I can solve. So 350T plus 400T is 750T. Okay? To solve for T, I divide both sides by 750. Okay? And when I divide this, I get 1.5. Okay? So, what this is telling me is that in 1 hour and a half, 1.5 hours, an hour and a half, that is when these two planes are going to be 1,125 miles apart. Okay? So this is the amount of time, 1.5 hours. And if you get to this point on the test, you are going to get most of your points. But what it says is, at what time will they be 1,125 miles apart? What time did they leave Nashville?
10 a.m.
10 a.m. So what time will that be?
11:30.
You got it. 11:30 a.m. So 11:30 a.m. is the actual answer. But 1.5 hours is the difficult part. Taking 1.5 hours and making it 11:30 a.m. is just your last step. That's when you have to read the question super carefully. But it's getting to the 1.5 that's the more difficult part. Okay? Okay, can we try another one?
Yes.
Okay. So the next one that we're going to do, these are what we call rational equations. Rational equations. Okay? And when we are solving a rational equation, what we have to do is we have to multiply everything by the LCD. So we are going to find the LCD, but then we're going to multiply everything times the LCD. That's what we're doing here. We're multiplying everything times the LCD. And when we do that, we end up eliminating the denominators. That's our goal. We want to eliminate denominators. Now, this can only be done because we have this equal sign right here. If we didn't have the equal sign right there, we could not do it. We can only do it because we've got the equal sign. So, in this particular problem right here, I have x squared over x plus 2 equals 4 over x plus 2. Now, for this particular problem, I don't have more than one factor. So what is my common denominator here?
X plus 2.
It's x plus 2. So all I have to do is I have to multiply x plus 2 times both sides. So I am multiplying x plus 2. Okay? When I do that, I have x plus 2 over 1 times x squared over x plus 2. Then I have 4 over x plus 2 times x plus 2 over 1. And when I do this, what am I left with?
Squared equals 4.
X squared equals 4. So if x squared equals 4, what does x equal?
2.
2, or we've got two values here,
Negative 2.
plus or minus 2. Plus or minus 2. Now, in this situation right here, I've got to go back and check. If I plug 2 in for x, that'll give me 4 in the denominator. Is that okay to have 4 in the denominator? Is it okay to have 2 plus 2 or 4 in the denominator?
No.
It is okay. It is okay. What is not okay is for me to have negative 2 plus 2. What happens with negative 2 plus 2? Negative 2 plus 2 is what? 0. Okay? So what you have to check for here is you've got to check for undefined values. You have to check for undefined values. That's super important. So when you get your answer, go back and see, ask yourself, does either value make the denominator zero? Okay? Does either value make the denominator 0? And in this situation, negative 2 makes it 0. So our only answer, the only answer here is positive 2. We have to throw the negative 2 out. We have to throw the negative 2 out. Now, this particular problem wasn't terrible, okay? It wasn't too difficult. So I want to do one that's a little bit more difficult, okay? Are you ready for me? Can I erase this, or are people still writing? Okay. So what we are going to do, whoa, those are my airplanes in Nashville. So I want us to try this one. Okay, and this is another one where we've got the equal to. We've got the equal to. So when we've got the equal to, we can multiply everything by the LCD. We're going to eliminate the denominator, which is our goal. So here I have 1 over b squared minus 7b plus 10 plus 1 over b minus 2 equals 2 over b squared minus 7b plus 10. Okay, what do you think the first thing I need to do here is?
Find LCD.
I do need to find the LCD. And the way that I find my LCD, what do I need to do with those denominators?
Eliminate.
Factor them. Factor them. Okay? So that's what I'm going to do. I'm going to go ahead and factor these. Now notice that b squared minus 7b, and these two are the same. So that's kind of a good thing. Those are the same. But go ahead and factor it because you're going to find this might be one of the factors. So I've got 1 over b, 10 is my product, negative 7 is my sum. So I'm looking for two numbers. Multiplied together gives me 10. Added together gives me negative 7. Multiplied together gives me 10. Added together gives me negative 7. And those numbers are going to be negative 5 and negative 2. Negative 5 times negative 2 gives me positive 10. Negative 5 plus negative 2 gives me negative 7. Okay, now here, I don't have to factor anything. I just have 1 over b minus 2. We have already factored this one, so we know it's b minus 5 and b minus 2. So, in identifying our LCD, I'm going to start here. I'm going to start here. And I'm going to just go ahead and write both of them down. b minus 5 times b minus 2. When I go here, I just need to make sure that the b minus 2 is covered. Is the b minus 2 already part of my LCD? Yes, so I don't need to write it down again. Okay? I don't need to write it down again. Then I go here and I've got b minus 5 and b minus 2. Are both of those already included right here? So I don't have to write it down again. So my LCD is b minus 5 times b minus 2. So what I'm going to do now is I've got b minus 5 times b minus 2, and I am multiplying that times all of this. So I've got b minus 5 over b minus 2 over 1. And now we're going to see how little I can write because it's not, I don't always do a good job of writing small. So I've got b minus 5 over b minus 2. I'm going to multiply that times 1 over b minus 5 times b minus 2. Okay, I'm going to do it again. b minus 5 times b minus 2 over 1. And that is multiplied by my second expression in here. So I have 1 over b minus 2. That equals 2 over b minus 5 times b minus 2. And that's my last expression. So I've got b minus 5 times b minus 2. I didn't do too bad. Okay? If it's on the top and the bottom, we can simplify it. Okay? On the top and the bottom, we can simplify it. So b minus 5 is here, and b minus 5 is here. b minus 2 is here, and b minus 2 is here. Okay? So I am left with positive 1. Now here, I've got b minus 2 and b minus 2, but what do I have left?
B minus 5.
b minus 5. So then I have plus b minus 5. Now this b minus 5 is multiplied times 1. The b minus 5 is multiplied times 1. So I'm distributing a 1, so it's fine. Okay? Then, for my last one, I've got b minus 5 and b minus 5, b minus 2 and b minus 2. So I'm just left with 2. Okay? So then I simplify. This is not a quadratic. It's just something linear that I solve. Okay, so my answer is b equals 6. Whoa, that says b equals b, doesn't it? How about this? You still have to check. You've got to make sure if you plug this in, is it going to give me an extraneous solution? Is it going to give me not an extraneous solution, but an undefined value? If I plug 6 into b minus 5 or b minus 2, is that going to give me 0 in either one of them? No, so I'm okay. So it's going to give me 0 here. So it's going to give me 0 here. So I'm okay. So my answer is b equals 6. b equals 6. Okay? Can I move off this screen? Okay, we're gonna come back to that in just a second, but I want us to talk about the difference between what we just did there and this right here. So I've got 1 over 2x minus 3 over 2x squared plus 3 over x, okay? What do you notice here that is different than here? What is missing? What is not included here? Equal sign, okay? So you've got your equal sign right here. There's no equal sign right here, okay? So my directions to this are going to say simplify. And this is one of the ones on the test or the final exam that I think is more difficult, okay? Because combining those rationals, that's not our strength. Essentially, we're adding and subtracting fractions is what we're doing. So this is one that I think students sometimes have a more difficult time with than the one that we just did, okay? So I've got 1 over 2x minus 3 over 2x squared plus 3 over x. Now, I'm simplifying, but the first step in simplifying is still finding my LCD. Okay, so I've still got to find my LCD. The difference is I'm not multiplying everything by my LCD in this situation. I'm making sure every one of my denominators has all the parts of an LCD. So this, you really want to make sure that you've got this. You want to practice. There's 2 on your practice final, and there's going to be 2 on your actual final. So focus on these. So my LCD, the first thing I'm going to do is I'm going to look at this one right here. I'm going to go ahead and write down the 2, and I'm going to write down the x. Okay, so I have 2 and I have x. Okay, my next step is I look right here. Remember, this is the same thing as 2 times x times x. Do I have everything included already, or do I need to add something?
Add 1x.
I need to add a second x, okay? Because I've got 2 times x, but in my LCD over here, I've only got 2 times x. So I've got to make sure that other x is included in my LCD. Now here, for my last one, I'm looking at this x. Is x already included in my LCD?
Yes.
Yes, so I don't have to add anything else. Now, the next thing that I would do, just to kind of keep everything straight, is I would go ahead and make this minus a plus, and I'd move that negative to the numerator. That's what I would do. Okay? Now, I have 1 over 2x plus negative 3 over 2 times x times x. I'm going to go ahead and write that out so I keep it straight. Plus 3 over x. Now, I ask myself, here is my LCD. Here is my first fraction. What is missing from my LCD? What's missing in 1 over 2x that's included in my LCD, x. So I am going to multiply the bottom times x. If I multiply the bottom times x, what do I have to do? Multiply the top. Okay? Is there anything missing in negative 3 over 2 times x? No. So I don't do anything to that one because it's already got everything that's in my least common denominator. 3 over x, what am I missing? 2x. So if I multiply the bottom by 2x, what do I have to do to the top? Multiply by 2x. Okay? Now I have my LCD accounted for. Okay? So every one of them have the same LCD. Now I just need to multiply and combine everything. So on my first one, I've got 1 times x. 1 times x is just 1x. If you wanted to just write x, you could. Then I've got minus 3 from my second expression. And then my third expression, I've got 6x. Is there anything I can combine there?
The x's.
Good. I've got 1x here, and I've got 6x here. So my final answer here is 6x minus 3 over 2x squared. Now, one of the things that students struggle with is the difference between this and solving. Here, we are simplifying. The directions will say simplify. Okay? We are simplifying. There is no equal sign. There's no equal sign. In order to simplify this, you must rewrite all expressions with a common denominator. Okay? You've got to rewrite each term. Okay? This is a term, this is a term, and this is a term. Rewrite each term with the common denominator. Okay? You got to do that. Rewrite each term with the common denominator. Then your answer is going to be some type of expression. You're going to have values squared. You're going to have x's. Okay? It's not equal to. You're going to have an expression as your final answer. Okay? See a couple people writing. Okay. Here, the directions are solve. Okay? Here, you multiply everything by the LCD. Okay? By your second or third step, you will have eliminated your denominator. That's your goal when you are solving. You want to eliminate the denominator. And the reason that we can do this way is only because we have that right there. Okay, if we didn't have the equal sign, we couldn't do it this way, then we would just be simplifying. Your answer here is a variable equal to a value. Okay? That's the difference. Now, students typically get confused. When am I solving and when am I simplifying? And rationals are where they get confused. So those are the difference between those two. Okay? Okay. Now, for our next one, it's another word problem, so you guys can take a second to write it down. Or you can take a picture. Whatever is best for you. Write it down or take a picture. So you know how a lot of you guys feel about mathematics, and it's kind of a fearful kind of thing? That's how my daughter and I feel about literature. And so she took a college level literature class this semester. She has a very, very low B, which makes her uncomfortable, but I keep telling her to get over it. And that was what she was texting me. So she got I didn't read it. I was trying to get it off really quickly, but it appears that she got an 84 on her paper. And I think it said an 80 on the test. And so I think that she's pretty excited about that. And she was able to pick really old classic like Homer, the Iliad and stuff like that. So there is an interest there. She's not doing like British literature or something like that, which is fabulous. British literature is fabulous, but I wasn't sure I was going to get my autistic daughter to embrace British literature. And so she's learning that, these are okay things. So, and I tell her all the time, remember how you feel about literature. That's how a lot of people feel about math. So don't go in there judging, because we got a whole realm of people that hate math like you hate literature. So it's been a learning experience for her. And so we got this written down as I digress to tell you about my wonderful children. Then my son is so happy because he now has a 64 in English. And he's proud of his 64 in English. Yes. See? Yeah. That's parenthood. So here we go. Width of a rectangle is twice its length. The perimeter is 104. Find the dimensions. So what we are going to do is we are going to draw a rectangle. That's the first thing that we're going to do. Then what we want to do is we want to focus on the width of a rectangle is twice its length. How do I write twice its length? 2x. Okay? So my width is 2x. So what would this distance be based on this? The width of a rectangle is twice its length. So if this is 2x, what would I write here for this part?
X.
I would write just x. Now that's one thing that you've got to learn when you're taking these tests. Don't look at the pictures to determine what's bigger or what's not, or what's smaller. Okay, because 2x is definitely bigger than just x, but the way we labeled it, typically your length is bigger than your width. So don't get upset about this when you end up labeling it and you've got 2x and x. Okay, now then I'm told the perimeter is 104. Now we have 2 times L plus 2 times W equals our perimeter. Some people prefer to think of that as my length plus my width plus my width is my perimeter. So perimeter is just going to be this plus this plus this plus this. I am adding my sides up together. That's how I get my perimeter. So it doesn't matter which one of these you use. If you just add all the sides up together, and that gives you your perimeter, you're fine. Or if you use the 2L plus 2W equals perimeter, you're fine. You're getting to the same place. So if this is 2x, what is this side over here opposite the 2x? So if this side right here is 2x, what's this side? 2x. Okay? If this side is x, what is this side? X. Okay? So I can do length plus width plus width. I can add it all up, and that's going to give me 104. Okay? Or I can do 2 times x plus 2 times 2x. Gives me 104. Either way is fine. So I have 2x plus 4x. think I wrote something down wrong. Oh, okay. I didn't. Okay. 2x plus 4x. What's 2x plus 4x?
6x.
6x. Okay, and I'm going to tell you right now, you're going to get a fraction. Okay, so we're dividing by 6. Remember, you don't get to have a calculator. You don't get to have a calculator. So you've got to do 104 divided by 6. 104 divided by 6. 6 goes into 10 one time. 1 times 6 is 6. Okay. 6 goes into 44 7 times. 7 times 6 is 42. Okay, so I'm left with 2. So I'm going to get a fraction here. So I have 17 remainder 2. But I need to write that as 17. The 2 is my numerator. What's my denominator?
10. 6.
I put it over 6. So x is 17 1/3. 17 1/3. Okay, so if my length is 17 1/3, okay, so this is 17 1/3 centimeters. I multiply that by 2, and so this is 34 2/3. Now, I will tell you, I don't think the one on the final exam has fractions like that. But so this one is a little bit more difficult than what's on the final exam. Okay.
So where does the 34 2/3 come from?
I multiplied 17 1/3 times 2. So I plugged the 17 1/3 because that's what x is. 17 1/3 is our x value. So our 2x is going to be that multiplied by 2. Good question. Okay. Can we go shopping? At Kohl's, because they always have like 30% off. Okay. Della bought a dress for $57.60 at a 20% discount. What was the original price of the dress? Now, this one's not bad if you can really wrap your mind around what's happening here. Okay? Della bought the dress for $57.60. $57.60 was not the original price of the dress. She is going to pay, she pays less than the original price. So since $57.60 is the sale price, is the original price going to be more or less of the $57.60? It's going to be more. Okay. Now, this $57.60 was a 20% discount. Okay? It was a 20% discount. If her discount was 20%, what percent of the dress did she pay for? 80. That right there is the place that students don't know what to do. Okay? So, if your discount is 20%, the amount paid is 80%. Okay? If your discount is 35%, the amount paid is what? What percent? 65%. Okay? So if your discount is 25%, what's your amount paid? 75%. That's the key. That step is getting this problem right or wrong. Being able to go from a 20% discount to paying 80% is the key. Right there. That's the key. Okay? So the way that I write this problem is I say 0.8. Where did I get 0.8 from? 80%. 80% and 0.8 is the same thing. So 80% of my original value is the amount that she paid for this. Okay? 80%. X is representing my original amount. Okay? X is the original amount. That's what I'm trying to find. The original price is what I'm trying to find. So I set this up by saying 57. And so what I'm going to do here, and you got to remember, you don't have a calculator. So I am dividing both sides by 0.80. And 0.80 and 0.8 is the same thing. So to do the math on this, I'm going to have 57.60 inside the box. I'm going to have 0.80 outside the box. So what I'm going to do is I am going to move this decimal spot over twice. This is how you divide decimals. And then I move this over twice. So what I'm doing is I'm actually doing 80 into 57.60. Okay? So I'm going to ask myself, how many times does 8 go into 57? How many times does 8 go into 57? 7 times 8 is going to be 56. You're right. Okay, so it is 7. Okay. 7 times 0 is 0. 7 times 8 is 56. Okay, so then 7 and 6, so I'm subtracting. Then how many times does 80 go into 160? Twice. And so $72 is my original price. Okay? The thing that you need to remember here, if you will just think about, does it make sense? Even if you get the wrong answer, you'll be able to identify that it's wrong. So if I did 0.2 times X from the 20%, I'm going to get a really, really high number. And you should be able to realize, well, 20% off is not going to be that much. So hopefully if you think, does this make sense, you'll be able to stop yourself and see that I need to go back and think about this again. So I'm telling you, it's this right here. That's the key to getting this problem right, is being able to recognize between the discount and how much was the percentage that was paid. That's the key to being able to get those correct. Okay? Okay, I want to do an exponent one. Here we go. I think I'm going to have to make it up. So if I've got r squared s, and all of this is raised to the third power, Then I have 2r raised to the negative 1. Or let's do negative 2. Okay? Now, the absolute first thing that I've got to deal with in both of these are these right here. I've got to deal with those first. And so what I'm going to do is I'm going to say r squared, and r squared is being raised to the third power. So that is r squared, and I'm raising that to the third power. So what do I do with the 2 and the 3? Multiply. So this is going to be r to the 6th. Okay? Then I'm going to have s to the what? Third power. Okay? And that is being multiplied times 2 to the negative 2 power. Your number in there has to be multiplied by that exponent as well. Or not multiplied, it has to be raised to that exponent. So I have 2 to the negative 2 power, r to the negative 2 power, and then s to the what? Negative 8, because I am 4 times negative 2. Now, all of this is going to go to the denominator. All of that's going to the denominator. So I have r to the 6th, s to the 3rd, over 2 squared, r squared, s to the 8. Okay, can I do 2 squared? What is 2 squared? 4.
Or wouldn't it be a negative 4?
Okay, that is a great question. You're talking about this value right here. Why isn't this negative 4?
Yes.
Okay, so what we're doing is we are raising this 2 to the negative 2 power. We aren't multiplying it times negative 2. We are taking 2 and we're raising it to the negative 2 power. Okay, so that's what we did right here. We've got 2 to the negative 2 power. When I move this 2 to the negative 2 power to the denominator, my exponent becomes positive. Okay, that's why. So if I've got 3 to the negative 3rd power, when I rewrite that, it's 1 over 3 to the 3rd. I would have had to have a negative in front of that 4. That's what I would have had to have. Okay? Now I can simplify. I've got r to the 6th and r squared. So my r's on the bottom are gone completely. What am I left with on the top? R to the what?
R to the 3rd?
Okay. I've got r squared on the bottom, so I'm going to subtract.
Oh, sorry, I read that wrong. It'd be r to the 4th.
Good. Okay. Now, I have s to the 3rd on the top, so that's going to be gone completely. What do I have left on the bottom? S to the what?
S to the negative 5th.
It's but in the bottom it'll be 5. Okay, so I would have s to the negative 5th in the numerator, but s to the negative 5th in the numerator becomes s to the 5th in the denominator. So my final answer here is r to the 4th over 4s to the 5th. I thought I saw one more I wanted to do. You definitely want to review your factoring. Review your factoring, because a lot of the problems you're going to have to be able to factor to solve. There's 3 factoring problems and there's 7 solve. Oh, I remember what I wanted to do. So you're going to have to factor to be able to solve. So that's one of the things that you want to be able to do. So review your factoring. Remember, there's no calculator. There's no calculator. Okay? The absolute best thing that you can do is the practice test. And you need to be able to do the practice test completely and totally alone. You may end up doing that practice test 3 times. You may do the practice test once watching my videos. You might do it again with a tutor. And then the 3rd time you might do it by yourself. But you've got to be able to do that practice test alone. I remember the problem that I wanted to do. So we're going to do x squared plus 14x plus 45. Okay? Now, your directions on this say solve by completing the square. So you have to complete the square on this. Okay? You have to. Because the directions say to solve by completing the square. Now, this can be factored. I'm telling you right now, this can be factored. Okay? So if I were to factor it, I have x squared plus 14x plus 45 equals 0. Okay? What's the sum?
45.
That's my product. 45 is my product. What's my sum?
14.
14. So I need 2 numbers multiplied together that give me 14, added together that equal 14, multiplied together give me 45. 9 and 5. So I have x plus 9 and x plus 5. Okay? So I end up with x equals negative 9 and x equals negative 5. Okay? This is where we're going. We know that's the answer. We've got to get negative 5 and negative 9. Those are our answers. But the directions say solve by completing the square. It's okay to factor this first in order to know where you're going. I actually would encourage you to factor this first to know where you're going. Okay? So, completing the square. First thing I've got to do is I've got to take that 45 and I've got to move it over. Moving it over. So I'm going to have x squared plus 14x equals negative 45. So I subtracted 45 from both sides. That's what I did. Okay? What's half of 14?
7.
Okay? And what's 7 squared?
49.
49. Okay? So I am adding 49 to both sides. Okay? So I've added 49 to both sides.
Can you say that one?
Yes, I am happy to. Okay, so what I did, this is my b value right here. Okay? So what I do is I take half of whatever my b value is. I divide it by 2. So 14 divided by 2 is 7. Then I square 7. So 7 times 7 is 49. That's where I get my 49 from. So this 49 right here, it is 1/2 of my b value squared. Okay, that's where that 49 comes from. It is 1/2 of my b valued squared. Then, whatever that value is, in this case it's 49, I add that to both sides. So I've added 49 to both sides. Okay? So, I'm left with x squared plus 14x plus 49 equals 4. Because I combined negative 45 and 49. I combined those. Okay? Now, I can factor this side. I can factor it. By design, it is a perfect square trinomial. Okay, so I have x plus 7 times x plus 7. Okay? 7 times 7 is 49. 7 plus 7 is 14. I can rewrite that as x plus 7 squared. Okay? This point, I take the square root of both sides. When I take the square root of 4, I have to do the plus or minus. Don't forget your plus or minus. Okay? So then I've got x plus 7 equals plus or minus 2. I got the 2 because I can take the square root of 4. That's how I got my 2. Now I subtract 7 from both sides, and I'm left with x equals negative 7 plus or minus 2. Now, a lot of people are going to want to stop there because sometimes we do. Sometimes we have plus or minus 2i. Sometimes we have plus or minus the square root of 3 or something like that. But this we can keep going. This becomes negative 7 plus 2, negative 7 minus 2. Okay, negative 7 plus 2 is negative 5. Negative 7 minus 2 is negative 9. Okay, did I get the same thing? And that was our goal, to get the same thing. Okay, that was our goal. Okay? Okay, so again,